All right, this lesson is going to be lesson 2-18, so it's the 18th lesson of Unit 2, and it has to do with horizontal asymptotes. But look, we discovered these vertical boundaries by the fact that you can't divide by 0, but there's also horizontal boundaries. So where do those horizontal boundaries come from? So here's the warm-up, and we have to see how these are the same. So the first thing is we need to think about parentheses right here. So that means that we have to distribute the division. So do this with me. We're going to do X. This is on page 201. So page 201 is where we are. And a little out of focus. So I'm going to refocus, hocus pocus, focus. There we go. So we have to divide X into each one of those. So it's going to be X divided by X plus 7 over X. And then X divided by X is 1. So this becomes 1 plus 7 over X. So that's how the equation is rewritten. It's by dividing. Well, this 1 is going to be important to us on the next page or so. Then this one here is not the same thing, right? Decide if each equation is true or false for the values of X that do not, okay. So this one here is the flipped upside down of it. This is not the same thing. This is the same thing, but you can't divide it backwards like that. So this one is not the same. These are equivalent to each other because I distributed the division. I divided each part by X. All right, so now we go to this problem right here, and it talks about publishing books. So if you know anybody, I've known a couple different people that have printed books to sell. The first one that comes to mind is our previous mayor, Drew Hastings. He's written a book, and so you have to have them printed and all that good stuff. And so it costs so much to have them printed, and then you sell them. Well, if you have less printed, it costs more, because basically the setup is the expensive part. Once you get it all set up and you start printing the books, then it's cheaper per book, and that's what this graph shows. So here's the cost equation. The cost is 120 plus 4x over x. All right, so we're going to do that division thing here. So we're going to write the equivalent thing. We're going to put parentheses here. We're going to divide x into that, so it's 120 over x, and then we're going to divide x into this plus 4. This would be another way to represent the cost equation. Okay, so now it says how much does it cost for 50 books and 100 books. So I just put in C of 50 would be 120 divided by 50 plus 4. All right, so break out the calculator here. 150 or 120, sorry, 120 divided by 50 divided by 50, and then plus 4 is $6.40. $6.40. That would be the cost. So let's see. 50 is right here, and then 640 is right there. That makes sense with the graph. So it's 50 over and 640 up. So this equation, right? This equation is this graph. They're the same thing. 100 books would be right there. And so for 100 books, it's a little bit more than 5. So how much more than 5? Well, we can figure that out. C of 100 is equal to 120 divided by 100 plus 4. That'd be 120, $1.20, right? Because you divide, move the decimal point 2 places. So it'd be $5.20. And if you look on there, yep, that looks like $5.20. Okay. So there's the amount that you pay, right, for the different amounts. So the more you print, the cheaper it is per book. The author plans to charge $8 per book. About how many should be printed to make a profit? So $8 would be about there. So anything more than, it looks like about 30 books. So I would say more than 30 books. But you're just going to break even. So you want to print a whole bunch of those and hopefully sell them. Part D is what is the end behavior of the graph? What's it say about in context? So if you go this way, right, it's cheaper per book. So the more you print, the cheaper per book. And then the less you print, the, let's see, opposite of cheaper would be more expensive per book. All right. So we can see that. Now, here's the deal with this. You see this 4? As x becomes larger and larger and larger, 120 divided by 1,000, 120 divided by 10,000, 120 divided by 1,000,000, this gets really closer and closer to 0. So our horizontal asymptote is right here. Our horizontal asymptote, our HA, right? See how it levels off at 4? So that 4 right there is letting us know that that's the cheapest it can be if you printed like infinitely many books, but you can't print infinitely. But it just keeps coming down. It'll never cross this 4 line. That's the horizontal asymptote. Okay. So now we can look here and we can say, okay, there's a horizontal asymptote at 4. Okay. This one's at -4. Okay. And then this one is at 1. And then this one is at -1. So these are where the horizontal asymptotes, and it's a y equals situation because it's horizontal line. So y equals 4, y equals -4. Down here, y equals 1, and y equals -1. So y equals always makes a horizontal line. All right, so let's see if we can match this up. Unfortunately, it flips over. So this -1, so that would say -1. So A is -1. So which one goes through -1? -1 is D. So this would be little a. Okay, so this is D. This one goes through -4. -4 is B. -4 is B. This one goes through 1 because you can see it has 1 right there. When you think it's bigger, that's 1. So 1 is C. If we look back there, 1 is C. And A is A 4? Yeah, A is 4. A is 4. That's this one. Okay. So A is y equals 4. That's A. B was y equals -4. Okay. C was y equals 1. And D is y equals -1. Okay, maybe that's what I should have written down when I was doing this before. So now, when we divide these, we get 1 over x, and then x over x cancels out, so you get 4. So this one's 4, and 4 is A. Okay, x divided by x is 1, plus 4 over x. Okay, well, that one has the 1 in it, so that one is C. And this one here would be 1 over x, and then x over x is -4. So this one would be B. And then this one here is 4 over x, and then x over x would be -1 with a negative there. This one's -1, this one's D. So there they all are. Okay. Where do we see the horizontal asymptote of the graph in the expressions for the functions? So it has to do with that constant right there when we have that rational function. Okay, so here's the deal with this. Okay, so here's the connection. So if we have this, we do x divided into that, x divided into that. They wrote it this way. The x's cancel out, you get 3. So 3 is your horizontal asymptote. And that's because as x gets larger and larger and larger, right, 1 over a huge number is basically nothing. So it has to level off at 3. All right, so that's kind of that's the theme of this lesson. So the first thing we're going to do is it asks us to divide this like we just practiced. So you put your parentheses, you divide that. Here, we're going to divide it again. So you're going to divide like we did before. Put your parentheses there, divide. Talks about the situation. Then here, again, you divide this. You're just trying to figure out if it's 3 or negative 3. So you're dividing x into that. That's pretty easy. And then we have some repeat questions. We have the zeros of the function, and you have to like match it up again. State the degree in the end behavior. Right, so there it is. That's your leading term. So what does that mean? And then down here, these are horizontal asymptotes. And horizontal asymptotes are created by dividing by 0. So you can't divide by 0. Right? So what number would be an issue there? What minus 3 is equal to 0? And then that's going to be the graph, right? So this would be for your vertical asymptote. Asymptote. All right, so there we go. That's the lesson. Do the purple page. Do the purple page on 207 and 208. Those 6 questions. Beautiful.